Good day and welcome back to Maths and Physics, Mr. Simons. Today's grade 10 algebraic expression lesson is on classwork, testing whether we can classify and identify our numbers using the number system taught in the previous lesson. Right, so if you look at the first variation of how we can test it, we say classification, classify the following numbers by ticking off the relevant numbers it belongs to. And I've already ticked off, but yeah. Let's solve. So if we have a number 4, we should know 4 is a natural number, right? But it will also appear in the list of whole numbers as well as integers. 4 can be written as 4 over 1, therefore it is a rational number, right? And it's a real number, meaning it forms part of the real number system, right? If we say 5 over 8, 5 over 8, right, is a rational number, meaning it's written in the form a over b. It's not a natural number because it's a decimal. It's not a whole number. It's not an integer because it's a decimal. But in fact, it is a rational number and a real number. For pi we should know is irrational, right? And because it's irrational, but it still forms part of the real number system. Negative 15 can't be a natural number. Natural numbers are all positive. Negative 15 can't be a whole number because whole numbers start by 0 and include all positive numbers, but negative 15 is an integer. Negative 15 can be written as negative 15 over 1, so therefore it's considered to be rational, right? And from there automatically it forms part of the real number system. 0 is not a natural number. We can't look in nature and say, oh, there's 0 of this thing. So there, technically we can if animals and so on disappear and become extinct. But yeah, so 0 don't form part of natural numbers, but whole numbers. So there's 0, integers, rational, at the same time real numbers. 0,23, right, it's non-reoccurring, so it's 23 over 100. It can be written, therefore it's a rational number and a real number. Square root 5, we assume you know 5 is not a perfect square, so therefore this is irrational and real. Square root of a negative number, negative 3, meaning it is non-real. They don't form part of the real number system we're working with. Cube root of negative 64, however, becomes negative times negative times negative, so that would give me negative 4. And negative 4 is then an integer, a rational number, and a real number. So don't, square root I can't find, but cube root I can. Square root of 64 is 8, so 8 is a natural number, it's a whole number, it's an integer, it's rational, it is a real. 9,45 stop, so it's a non-recurring decimal, so therefore rational, real. 1,0909 also rational, real. Alright, so that's the first. So we can test this using a table. Alright, we can also test it. If you look, identify the following numbers as real, rational, integer, natural, irrational, or no number. You may use more than one term for each number. Now, very important that we know what each letter represents. Alright, these Greek-like symbols. So n there's natural number, n with a 0 is a whole number, z is integer, q is rational, q dash or irrational, and r for real numbers. So a, 0 divided by 5 gives me 0. So 0 forms part of whole numbers, forms part of integers, forms part of rational numbers and real numbers. P, negative 5 is an integer, rational and real. Right, 0,38 can be written as 38 over 100, so therefore it's rational and real. T, negative 0,76, right, can also be written as negative 76 over 100, so therefore it's a rational and a real number. 5 over 9, it's in the form a over b, so therefore rational and real. 0.9 reoccurring is the same as 99999. Right, so that there rational and real. Same here with recurring, be rational and real. 15 there, non-perfect square, so square root of 15 would be irrational and real. So that's the second way we can ask you to classify your numbers. Right? Then we have where we're going to give you expression and you have to answer questions from the expression. So let's look at the third variation. Right? So if L equals square root x plus 6, for which values of x, and there we have x minus 5, x plus 1, is L real, L equal to 0, undefined or non-real. Right, so number 1, for it to be real, I assume you remember a square root cannot be negative. Right, so x plus 6 then, if it's not negative, to be positive, it must be greater or equal to 0. So therefore, if I take 6 over, x must be greater or equal to negative 6. So negative 6 plus 6 gives me 0. If I put a value greater than that, minus 5, I only end up with positive values. But if I took a value like minus 7 plus 1, I have square root of negative 1, which then makes the whole thing non-real. Take note, x cannot equal 5 or x cannot equal minus 1. These are greater than, because if it equals those two totals, the whole item becomes undefined. So I have to specify that if I put 5 minus 5, anything divided by 0, undefined. If I put minus 1 plus 1, 0, anything divided by 0, undefined. But you see there, 5 is bigger than negative 6 and negative 1. So that is my restriction I have to specify. For which values is x? Is L equal to 0? So L can only be 0 when the top is 0. So there we would say square root x plus 6 equals 0. If I square both sides, that will leave me with x plus 6 equals 0. If I take 6 over, x equal to negative 6. So negative 6 plus 6 would give me 0. Square root of 0 is 0. 0 divided by anything stays 0. When does it become undefined? When the bottom is 0 of the fraction. So there, x minus 5, x plus 1 equal to 0. If I take negative 5 across, x equal to 5. If I take plus 1 across equal to equal sign, it becomes minus 1. So when x equal 5, 5 minus 5, 0. Minus 1 plus 1, 0. So if the bottom is 0, the whole equation is undefined. When is it non-real? Remember, the square root must be negative. So if I say x plus 6 less than 0, so if I say x, if I take plus 6 over, it becomes negative 6, x less than negative 6. So less than negative 7 plus 6, negative 1, square root of a negative, non-real. If I go negative 8 plus 6, negative 2, non-real. Right, so I hope you follow. This is my basic introduction. We'll still do many other exercises and exam questions. In the end, this is just the introduction of what you need to know. All right, all the best. God bless. Bye.